so today we're going to be talking about 9.3, which has to do with solving different types of equations that we haven't necessarily seen before that end up in some like quadratic form. Okay, so numbers 1 and 2 shouldn't be too foreign to us. We've done problems very similar to both of these. They're not actually really new content at all, but a fun reminder from previous chapters. And then number 3 is a little bit different, but we're going to go ahead and just go through these examples. So first up, we have x minus the square root of x minus 6 equals 0. And so to solve radical problems, remember that we want to first isolate our radicals. So I'm going to add square root of x to the other side. So I get x minus 6 is equal to the square root of x. In order to get rid of that radical, I'm going to raise it to the power of the index, which is squared. So over here I get x. And then let's see what x minus 6 times x minus 6 is. Remember, that's a binomial times a binomial. So you've got to FOIL it out. So it's going to be x squared minus 6x minus 6x plus 36. So that's x squared minus 12x plus 36. So we get x squared minus 12x plus 36 is equal to x. I'm going to subtract x to the other side. So I get x squared minus 12x plus 36 is equal to 0. I'm going to factor that bad boy. So on top, 36, negative 12. That is going to be, oh, I subtracted x to the other side. This should be 13. I wish that I was in class teaching this and you guys could have been like, Miss Hogan can't be wrong. Everyone makes mistakes. It's okay. It totally happens. So don't get down on yourself. But anyway, minus 13x. So this is supposed to be a negative 13 down here. And that makes more sense because now negative 9 and negative 4 work. Where's my brain right now? Negative 9 and negative 4. So I'm going to get x minus 9 times x minus 4 is equal to 0. X minus 9 equals 0. X is equal to 9. X minus 4 equals 0. X is equal to 4. And as usual, we need to check our work by plugging into the OG equation, which is this guy right here. You don't actually have to call it that. I just like making funny notes for myself in my math notes. So then when I look back over them, I'm like, haha, that's funny. Anyway, 9 minus square root of 9 minus 6 equals 0. 9 minus 3 minus 6 equals 0. 9 minus 9 equals 0. 0 equals 0. Check. 9 is the solution. 4 minus square root of 4 minus 6 equals 0. 4 minus 2 minus 6 equals 0. 4 minus 8 equals 0, negative 4 equals 0. Not true, doesn't work. So my solution is x equals 9. All right, next up, we have 3x over x minus 2 minus x plus 1 over x is equal to 6 over x times x minus 2. So remember, when we are solving problems that have variables in the denominator, it's important for us to get those variables out of the denominator by multiplying by the least common denominator. And our least common denominator has to account for each factor that you see in your denominator to the highest power. So if I'm looking at my denominator, the two factors that are C are x minus 2 and x. So that is going to be my LCD, and I'm going to multiply it by each term in my equation. So I have 3x times x minus 2 times x over x minus 2 minus x plus 1 times x minus 2 times x over x equals 6 times x minus 2 times x over x times x minus 2. And then beautifully, I see that in my first term, I get a nice little cancellation of x minus 2. In my next term, I get a cancellation of x. And in my final term, x minus 2 and x both cancel. So take a second and look at and see how you get from step 1 to step 2 and how that eliminates your denominators, okay? Because we can't solve for x if it's in the denominator. Doesn't work. So we got to get it out of there. So now we have 3x times x, which is 3x squared, minus x plus 1 times x minus 2 equals 6. Let's figure out x plus 1 times x minus 2. X squared minus 2x plus x minus 2 is x squared minus x minus 2. So we have 3x squared minus quantity, careful here, you're going to have to distribute that negative, x squared minus x minus 2 equals 6. So 3x squared minus x squared plus x plus 2 equals 6. So that's going to be 2x squared plus x minus 4 equals 0 because I subtracted that 6 to the other side. And so I get 2x squared plus x minus 4 equals 0. This equation cannot be factored. So we are going to have to rely on our handy dandy quadratic equation, which we know always works. A2, B1, C, negative 4, x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 4 all over 2 times 2. So that will be x is equal to negative 1 plus or minus the square root of 1 plus 32 over 4, which is going to be equal to negative 1 plus or minus square root of 33 over 4. There's no perfect squares that divide into 33. I can't simplify that at all. There's no coefficient that I could divide out. So my final answer is literally going to be x equals negative 1 plus or minus square root of 33 over 4. So that is why the quadratic equation comes in handy. If we go ahead and plug in, if we get to this point right here where we're looking at an equation that can't be factored, now we have something to fall back on. So that's exciting. All right, last up, we have x to the 4th minus 3x squared minus 4 equals 0. So one thing that you'll notice about this equation is that it's almost a quadratic, right? It looks so close to being x squared minus 3x minus 4 equals 0, which we know how to solve, but it's not. So we're going to do something tricky here, okay? And I'm going to choose another letter. I'm going to pick H for Ms. Hogenkamp. So what I'm going to do is I'm going to say that H is equal to x squared, okay? And so if H is equal to x squared, I can rewrite my equation as H squared, because if H is x squared, then H squared is x to the 4th minus 3H minus 4 equals 0. And doing this little substitution allows me to now factor my H squared minus 3H minus 4. So on top, I'm going to have minus 4 minus 3. That is going to have to be 4 times 1 and negative 4. So I'm going to get H minus 4 times H minus 1 equals 0. And then at this step, I'm going to back substitute, or that's supposed to be a plus 1. And I'm going to say, well, H was equal to x squared. So now I know x squared minus 4 times x squared plus 1 equals 0. So basically, for these problems that have something to the 4th minus something squared minus a number, those equations that are almost quadratic, you can make them quadratic using like a little tricky substitution. Okay, so then x squared minus 4 equals 0. So x squared equals 4. So x is equal to plus or minus 2. Okay, and then x squared plus 1 equals 0. X squared equals negative 1. Square root of negative 1 is I. So my 3 solutions here, or I guess 4, because whenever you take a square root, plus or minus. So my 3 solutions here are going to be positive 2, negative 2, I, and negative I. Okay, so again, this is really, really similar to a quadratic, and all you have to do is do a little bit of tricky substitution. And if you don't see this, think about like, okay, H squared is x to the 4th because H is x squared. So H squared is the same thing as x squared, which is x to the 4th. Okay, so that's how this whole like step kind of happens. So think about that. And these are the new types of problems that you can now solve. They're kind of a review a little bit actually, but anyway, happy watching, happy problem setting, and bring any questions you have to class. Thanks guys.